Energy crisis. This is a term that you should be familiar with by now. Rising demand coupled with disruptions to supply chains have meant that energy prices have soared. This has created greater urgency in finding new ways to generate energy from a variety of local and sustainable sources that will make the European energy grid more resilient against shocks, while simultaneously making the process of energy production more circular and less impactful on the environment. One solution is biomass. Some of the most common types of biomass used for energy production are wood, agricultural residues, energy crops, and waste cooking oils. However, many questions remain over their availability, their use of land, or impact on the environment. So what we need is a sustainable and abundant source of biomass that doesn't use or degrade land. Waste. Human societies produce a lot of it. Billions of tons each year, the majority of which is industrial waste. Businesses have gotten pretty good at managing and exploiting their waste in order to maximize their profits, but their ability to do so heavily depends on the technology and infrastructure available. And quite often, it is more cost-effective to just dispose of the waste via incineration, landfilling, or for use in agriculture. So what is needed for the EU to successfully transition to a circular, sustainable and green economy are industrial-scale technologies that are flexible enough to process a variety of waste streams in a cost-effective way, reducing environmental impact, and produce bioenergy and other valuable products that can help the EU maintain a flexible energy system and generate revenue for businesses. The FCUBED project could have the answer. FCUBED aimed at producing biofuel in the form of intermediate bioenergy carriers from 3 industrial waste streams of paper sludge, olive pomace and orange peels. 3 pilot plants consisting of the Torwash reactor and Limburg filters dewatering technologies were set up at the Smurfit Kappa paper mill in Sweden, the Appo olive oil mill in Italy and the Delafruit facility in Spain.
The heart of the FCUBED project is what we call the FCUBED process, and that consists of Torwash hydrothermal treatment and the dewatering. So Torwash is really at the heart of what we're doing in this project.
Torwash is a hydrothermal treatment process we use to treat and upgrade wet organic residues.
The waste stream is fed into the Torwash reactor where it is hydrothermally treated.
Torwash is explicitly done at a temperature just above a critical temperature where this chemical surface changes and it becomes easy to be water.
The treated waste stream is then fed through the specially designed filter press, where the solid and liquid fractions are separated into solid cakes and a filtrate. The solid cakes are dried and pelletized, ready for combustion, and the filtrate can be used to extract nutrients and oils and produce biogas. The combustion testing of the biofuel pellets was conducted in a rotary kiln under conditions with varying temperatures, feeding capacities and residence times. All 3 fuels performed very well and were processed continuously in stable conditions for a period of several hours. This not only proved the suitability of the biopellets for use as a fuel, but also allowed for analysis of the environmental impacts, such as the amount and type of emissions and byproducts, and therefore the sustainability of the entire process could be evaluated, from feedstock collection to energy generation. But for the process not just to be sustainable, but also economically viable, the extraction of the maximum value possible from the waste streams must be achieved. Therefore, the remaining filtrate from the hydrothermal treatment and dewatering process was tested for its potential to produce biogas and the extraction of nutrients and oils. The filtrate still contains organic material that can be used for generating biogas in an anaerobic reactor, and the anaerobic biodegradability testing demonstrated that all 3 feedstocks are suitable for biogas production. As I mentioned, the removal of salts from the solid fraction is vital to the performance of bioenergy pellets as a fuel. What this means is that these salts and nutrients are present in the filtrate and can be extracted and utilized for fertilizer applications or recycled back into manufacturing processes. This can be done directly from the filtrate or from the anaerobic digestate following biogas production. Oils from the olive pomace and orange peels are also present in the filtrate, which can be separated and used for both industrial and commercial applications. Overall, the FCUBED project using tool wash and Limburg filter technologies demonstrated that the production of bioenergy carriers, biogas, and extraction of nutrients and other value-added products is possible from industrial biogenic waste streams. And now we're going to tell you how this is not only beneficial for the environment, but also for businesses. Industrial waste streams can be difficult and expensive to manage. The FCUBED process can help businesses reduce costs and manage their waste by efficiently converting it into new products that have industrial and commercial value.
And what we hope to show with the project, through the modeling work that we do, is that it offers an advantage in terms of not just costs, so residue handling costs, but also in terms of greenhouse gas emissions reductions. And this is really important because from an industrial point of view, it shows an alternative to what they're currently doing, and it shows a use for biomass as a feedstock for energy production.
The advantage of tool wash compared to other existing technologies is that it allows for a very efficient dewatering and upgrading of the solids to a FCUBED while running an energy neutral process.
And it will greatly decrease the environmental impact by reducing harmful substances being discharged into the environment. Businesses are increasingly under pressure from the public and governments to reduce their environmental impact and engage in more resource-efficient and circular processes. But they cannot do this alone. They need the help of the scientific community to develop technologies and processes that fit well with their existing infrastructure and are economically viable. The FCUBED process can help businesses achieve their sustainability targets whilst also generating additional revenue streams and produce products and energy that can be utilized internally, thus reducing operating costs. The FCUBED project has demonstrated that the tool wash reactor and Limburg filters dewatering technologies can process waste streams from the paper, olive and fruit industries and create bioenergy and value-added products. But what has also been demonstrated is that these technologies are extremely flexible, and there is a potential for their application in a wide variety of industries that generate large amounts of biogenic waste streams.
So our plans for the future are quite versatile. We want to extend the work on agricultural residues or residues from food industry, but also we are developing the dewatering of sewage sludge.
Currently, we are scaling up this technology for industrial and communal sewage sludge. Right now, we're scaling up by a factor 20 compared to the existing pilot plants. This demonstration plant is going to be installed at a communal wastewater treatment plant in the Netherlands. Just to give you an example of how big such a waste stream is in the Netherlands, 1.2 million tons of sewage sludge becomes available at the wastewater treatment plants. Communal wastewater treatment plants pay between 100 and 115 million euros per year in order to process this waste.
More research is needed, but what is clear is that technologies like tool wash and Limburg filter can play a pivotal role in the EU's transition to a green and circular economy and provide greater stability and resilience to an energy system that, at the moment, is strained and overly reliant on imports of fossil fuels. FCUBED has shown there is an alternative to business as usual.